So now we're going to keep graphing and looking at writing equations for linear functions, but now we're going to look at point-slope form. So we looked at slope-intercept, now point-slope. Well, it is just what it sounds like. If I can get this to go to the next one. Point-slope uses the point and the slope. So any point on your graph and the slope. And our point-slope form is actually y minus y1 equals m times the quantity x minus x1. Okay, this y and x, these are our variables, so they're going to stay x and y no matter what. The m is our slope, just like it has been in the other equation. This is our slope. And then x1, y1 is whatever the point is that you're using. So if your point is 5, 2, you would plug in 5 and 2 for your x1 and y1. Okay, pay attention. This is y minus y1. So if you have a negative y, if I did y minus negative 2, that double negative is going to become y plus 2. So it's kind of like opposite sign, like we looked at when we were talking about our transformations left, down, or left, right, up, down. Okay, so it is always a minus unless you're working with negatives, and then it's going to switch to a plus. So graphing in point-slope form. Alright, you've got two options really. One is just to look at it using your point and your slope. So I've got y minus 2 equals 3 times x minus 1. So my slope is right here at 3, and then my point is going to be whatever's in parentheses with the x and whatever's with the y on the other side of the equal sign. So a positive 1, positive 2. Remember, our equation is y minus y1, so it's going to always be a minus unless you have a negative number, and that's when it's going to change to a plus. So one option is to go to my point, 1, 2, and put a point, and then just use my slope. So my slope is 3, or 3 over 1, so I'm going to go up 3, right 1, or down 3, left 1. Okay, as many times as you want to. At least 2 points is all you really need, and this is a very crooked line. But nonetheless, it's my line. Okay, the other option you have is to move it from point-slope form to slope-intercept form, which sometimes is easier than others. Like this first example was pretty straightforward, putting it in point or using it in point-slope form. The second one, I only need to do one quick adjustment to get it to slope-intercept form, and that is subtract 1 from both sides. Right? So then I would have y equals 1/2 x minus 1. So my slope is 1/2 and my intercept is at negative 1. Right? So then I could go to my graph, go to negative 1, put a point, go up 1 over 2, up 1 over 2. Right? Or down 1, left 2. So whichever way you would prefer to graph point-slope form is completely up to you. If you really prefer slope-intercept form, move it to slope-intercept form. If you prefer point-slope form, just finding your slope and your point, leave it like it is. Alright, just keep in mind, this one down here, I don't really have parentheses, but if you were to imagine adding in parentheses, right, there's nothing there, which means it's the same as x plus 0. So then my point would be at 0, negative 1, which works out to be my y-intercept. Alright, and then this one you would have to distribute your 3, and then add the 2 over to both sides, and kind of combine your like terms to get down to slope-intercept form. Just two different options. Writing equations in point-slope form. It's actually much easier than slope-intercept form. You have less steps. So for the first one, I want to write the equation of a line that passes through the point 2, 1 and has a slope of negative 4. Alright, so this is my m. This negative 4 is my m. And then 2, 1 is my x1, y1. Remember, slope-intercept form is y minus y1 equals m times x minus x1. So I'm just going to plug everything in. So I have y minus my y of the point, which is 1, equals my slope, negative 4, times x minus the x of my point, which is 2. And that's it. You also might have a question where you write the equation that runs through 2 points. So it's similar, but I'm not given the slope. I have to find the slope. So to find the slope, I do y2 minus y1 over x2 minus x1. So we would have 7 minus 2 over 8 minus 5. 7 minus 2 is 5. 8 minus 5 is 3. So my slope is 5/3, and I just can pick a point. Doesn't matter which one. So I could say y minus 2 equals 5/3 times x minus 5. Alright? Or you could use this 0.87. The beauty of this is that if you were to move it to slope-intercept form, regardless of which point you use, it would still all end up the same. And you can also use point-slope form to write equations in slope-intercept form. So instead of having to plug in points and solve for b and then re-plug in b and everything, you could just use point-slope form and then multiply everything out to get the slope-intercept form. So for this one, I want to write the equation of a line that passes through 3, 5, and 5, 4. So again, I've got to find my slope first. So I've got 4 minus 5 over 5 minus 3. 4 minus 5 is negative 1. 5 minus 3 is 2. So I've got a slope of negative 1/2. So I'm going to say y minus, I'll just pick the first point, it's an easy one. Y minus 5 equals negative 1/2 times x minus 3. There's my point slope version. Now I just have to multiply everything out and get y by itself to get the slope intercept. So I'll start by distributing. So I have y minus 5 equals negative 1/2 x. Negative 1/2 times negative 3 is positive 3/2. And then I just have to add 5 to both sides. We have to work with fractions. Oh my goodness. 3/2 plus 5. I have to get a common denominator. It's 5 over 1. My common denominator is 2. So that's the same as 3/2 plus 10 over 2, which is 13 over 2. So it's y equals negative 1/2 x plus 13 over 2. So point slope can be pretty handy when putting in slope intercept form too. Just depends on which way your brain thinks.